Good evening, sir. Good evening, all of you.
Good evening, sir. Good evening, sir.
Very
Good evening, sir.
So yesterday, what did we complete? Chemical kinetics, right?
Yes, sir.
Okay. So let us start a new chapter. I think we have to complete surface chemistry. Yes. So this is theory part only. Surface chemistry is all about theory. So let us see surface chemistry. Mr. Charan Kumar, don't draw anything. Your name will come here. So surface chemistry. Okay, let us start. Surface chemistry is all about chemical processes which are taking place on surface of substances. Okay. Then, so what we are going to learn in this chapter. The first part in this chapter, we are going to deal with the adsorption phenomenon. So we'll deal with only right. So let us see. Adsorption. Now let us consider this is adsorbent. What is this? Adsorbent. On the surface, who are present? Adsorbate molecules. So the accumulation of adsorbate molecules on the surface of adsorption, this is what we call adsorption phenomenon. So this is what we call adsorption phenomenon, right? Now, if same adsorbate molecules penetrate into the bulk like this, then this is called absorption. This is what we call absorption. Okay. Then next is sorption. If both adsorption and absorption takes place simultaneously, then it is called sorption. If both the adsorption as well as sorption takes place simultaneously, then it is called sorption. Then what is desorption? Desorption is removal of adsorbate from the surface of adsorbent. Okay, so this is what we call desorption. The next types of adsorption. There are two types. First one, positive adsorption. What is positive adsorption? If, okay, so I'll give you, I will explain through an example here. Let us consider adsorbent. Okay, now on this, if the particle concentration, that means the adsorbate molecules are present more on the surface. The adsorbate molecules are present more on the surface than in the bulk. Then this is what we call positive adsorption. That means more number of particles on the surface than in bulk. Bulk means in the interior, right? This is positive adsorption. Next, negative adsorption. So take it in opposite way. Consider an adsorbate like this. Okay, then if adsorbate molecules on the surface is less than the molecules penetrate into the bulk. So here more number of particles in bulk than present on the surface. So that is what we call negative adsorption. For this, example is when concentrated KCl is shaken with charcoal, then positive adsorption takes place. Whereas when dilute KCl is shaken with charcoal, then negative adsorption takes place. So this is about positive adsorption, negative adsorption. Next classification that you know very well, physical adsorption and chemical adsorption. Physical adsorption and so physical adsorption, it is due to weak van der Waals forces. So this is chemical adsorption. This is due to strong chemical forces. It is multi-layered process. Physical adsorption is multi-layered. And this is uni-layered. It's a fast process. This is a slow process. Nature of adsorbate will affect physical adsorption. Here in this case, both adsorbate as well as adsorbent, both will affect. Right. Then for physical adsorption, delta H enthalpy 20 to 40 kilojoules per mole. Whereas for this, delta H is equal to 40 to 400 kilojoules. 40 to 400 kilojoules per mole. Next, thermodynamical aspect of adsorption. What does that mean, sir? Thermodynamical aspects. So delta H. 1 minute. Delta H is negative. Okay, I'll start from this. Adsorption is an exothermic process. What does that mean? Delta H is negative. Then delta S, change in entropy. Before adsorption, after adsorption. What is entropy? That is also negative. Then delta G. Delta G is also negative. Okay. Next. Factors affecting adsorption. Next topic. Factors affecting adsorption. That first one. nature of adsorbate. So how nature of adsorbate will affect cell? Higher the critical temperature, more is the adsorption. So as critical temperature increases, adsorption also increases. Okay. The next factor, effect of pressure. Physical adsorption increases with increase in pressure. Increase in pressure. So here effect of pressure is explained by Freundlich adsorption isotherms. Adsorption isotherm means isotherms at constant temperature. Okay, so according to him, extent of adsorption is proportional to P power 1 by n, or x by m is equal to K into P power 1 by n. We take log on both sides. Log on both sides. So what will happen? Log x by m is equal to log Kp power 1 by n. Then what it will become? Log x by m is equal to log k plus 1 by n log p. So this is logarithmic form of Freundlich adsorption isotherm. Then, so let me write that equation one by one. Log x by m is equal to log k plus 1 by n log p. Phi is equal to mx plus c. So equation of a straight line. This is equation of a straight line. Then if you plot a graph, you will get like this. Okay. Now in this, let us identify the terms present in this. What is C, sir? Log K. Log K is C. That means intercept on y-axis. This is log K. Plot is plotted, drawn between log x by m. And here it is log P. Then what is slope, sir? Slope is equal to, what is slope? M. That is 1 by n. So slope is equal to 1 by n. Next topic, catalysis. What is it? Catalysis. What is catalysis? The substance which increases the rate of reaction is known as catalyst, and the phenomenon is known as catalysis. Then first one, homogeneous catalysis. What is homogeneous catalysis?
Reactants and products having same phase of elements.
Repeat it.
Reactants and products having same phase of elements.
Reactants and products, isn't it?
Same phase of catalyst.
When the reactants and the catalyst are in the same phase.
Yes. This is regarding catalysis. So if reactants and catalyst are in same phase, then we said to be homogeneous catalysis. Example, SO2 plus O2 in presence of NO, this is catalyst, sir. We'll get SO3. Okay. No, this is not 2 here, SO2. Right. Now this is sulfur dioxide is gas, oxygen is gas, nitrous oxide, sorry, nitric oxide, that is also gas. So here both reactants and catalyst, they are present in gaseous phase. Hence it is known as homogeneous catalysis. Next one, heterogeneous catalysis. In that 2SO2 plus O2 gives rise to 2SO2. Here vanadium pentoxide. Now SO2 is gas, oxygen is gas, vanadium pentoxide is solid. Now reactants and catalyst, they are present in different phases. Next one, autocatalysis. If one of the intermediate form during a reaction acts as catalyst, then it is called autocatalysis. Okay, arsenic hydride is dissociated into arsenic plus 3H2. Now this formed arsenic will act as a catalyst. So we are not adding any external catalyst. So one of the product formed will act as a catalyst.
Sir, sir, what is the difference between positive and negative catalyst?
Positive and
Negative catalyst.
positive catalyst will increase rate of reaction. Negative catalyst will decrease rate of reaction. Okay.
Okay, sir.
Next, catalytic poison. Catalytic poison. So what is catalytic poison? Which reduces the activity of catalyst. Example, in Haber's process. In Haber's process, carbon monoxide acts as catalytic poison. That means which inhibits or which reduces the activity of catalyst. Okay. Then shape selective catalysis. Shape selective catalysis. Shape selective catalysis means depends upon the pore structure of the catalyst. It depends on the pore structure of the catalyst. So here, an application is given in your syllabus, that is geolite. Okay, so geolite is having case-like structure. There is an artificial geolite, ZSM5. What is the role of ZSM5? It is also a catalyst which converts alcohol directly into gasoline. Gasoline means fuel, petrol. So ZSM5 is used to convert alcohol into gasoline. Okay. Next, second part in this chapter, colloidal solutions. So what are these colloidal solutions? So these are heterogeneous mixtures. In colloidal solution, we have dispersed phase and dispersion medium. Dispersed phase is nothing but solutes. Dispersion medium is generally considered as solvent. Now let us see some applications here. Dispersed phase, dispersion medium. Okay. You'll see different examples here. Here we consider system. Let us suppose smoke in dispersed phase are carbon particles. Smoke, carbon particles dispersed in air, lead, albuminoids dispersed in water, cloud, water droplets dispersed in air, gold sword, gold particles dispersed in water, starch solution, starch molecules dispersed in water. Then classification. So how we can classify that? In the first one, lyophilic colloids. Lyophilic means lyo, solvent, file, loving. So solvent loving colloids. So they are stable. Lyophilic colloids are stable colloids. Okay. Second one. Lyophobic colloids. What do you mean? Here example, you consider starch. Lyophobic colloids as usual, lyo solvent, phobic, hating. Example, gold sore. What is example, sir? Gold sore. So this is about classification. So classification based on dispersed phase. Dispersed phase. In that first one, macromolecular colloids. Examples, starch, proteins, multimolecular colloids, gold sole, associated colloids, soaps, okay. In these associated colloids, they form micelles. So let us see micelle formation. How micelles are formed? If you consider C17, H35, CONA. What is this? Sodium stearate. Then dissociates into C17, H35, CO minus plus Na plus. This is stearate anion. Now this stearate anion is represented like this. So this tail part, this is C17, H35. This is a hydrophobic end. And this head part, this is CO minus. This is a hydrophilic end. What happens? This simple soap anions will associate together and forms a giant molecule like this. Okay, now interior space. So this is the interior space. Now in the interior part, dirt, grease particles are captured. That is how we'll clean our clothes. So this is also known as cleansing action of soap. So soap acts as emulsifying agent between water and dirt. Okay. Next, preparation of colloids. How we can prepare the first one, mechanical dispersion. Second, electro dispersion is also known as Briggs arc method. Third one, peptidization. What is peptidization?
The process of conversion of a freshly prepared precipitate into colloidal from by the addition of suitable electrolytes, sir.
So precipitate is converted into colloidal sized particles by the addition of an electrolyte. So this method is called peptidization. Example, FeOH taken thrice. This is precipitate, ferric hydroxide. Now when you add ferric chloride, this is electrolyte. Now what will happen? Ferric hydroxide is formed. This is sold. Okay. So this is important. Briggs arc method and peptidization. These two are important. Next, purification of colloidal solution. There are other methods also, but we don't have time to discuss. The first one, dialysis. Next, electrodialysis. Third one, ultrafiltration. These three are purification methods of colloidal solutions. Then, properties of colloids. The first one, optical property. So optical property is studied under the name of Tyndall effect. So what is Tyndall effect? Scattering of light. by colloidal particles. For these applications, blue color of sky and the sea. Next, visibility of tails of comets. Next, twinkling of stars. So it's about optical property. Next property, kinetic property. Kinetic property is also known as Brownian. What is Brownian movement? Zigzag motion of colloidal particles. So it's a zigzag motion of colloidal particles. Okay. Next. Coagulation. What is coagulation? What is coagulation? Precipitation of colloidal particles by the addition of an electrolyte. This is explained by Hardy-Schall's rule. What is Hardy-Schall's rule? Higher the charge on ion, more will be its coagulating power. So 10 plus 4 will have more coagulating power than aluminum plus 3, than barium plus 2, than Na plus. Why tin is having more coagulating power? It is having high charge. We are having high charge. Next one, fluctuation value or coagulation value. What is fluctuation value? The minimum amount of an electrolyte in millimoles needed to fluctuate 1 liter of a sol means colloidal solution, is known as fluctuation value. So fluctuation value is inversely proportional to coagulation power. Next, gold number. What is gold number? The amount of protective the amount of substance in milligrams. Milligrams which, this is milligrams, which prevents the coagulation coagulation of 10 ml of gold soap by adding 1 ml of 10% NaCl solution. Then smaller the gold number, greater is its gold number, greater is its protecting action. Next, emulsions. So dispersion of a liquid into another liquid. Types: oil in water type emulsion. Oil in water type emulsion means oil is dispersed in water. Example for this: milk, vanishing cream. Next, opposite to this, water in oil type. Water is present in oil, that means oil percentage is more, water is less. Example for this: cold cream, cod liver oil. Okay. Now let us move to questions. So all are theory based questions only. So question number 1. In Friendlish adsorption isotherm, the value of 1 by n is options between 0 and 1, between 2 and 4, 1 in case of physical adsorption, 1 in case of chemical adsorption. So what is Friendlish adsorption isotherm? So answer for this, 1 by n value always like this, between 0 to 1. 0 to 1. What is Friendlish adsorption isotherm? X by m is equal to Kp power 1 by n. If 1 by n is equal to 0, then x by m is equal to, this is 0, then k. So if 1 by n is equal to 0, it is independent of pressure because there is no pressure term here. It is independent of pressure. Or 1 by n is equal to 1, then x by m is equal to Kp power 1. So x by m is proportional to pressure. So if n is equal to 1 by n is equal to 1, then extent of adsorption depends on pressure. If 1 by n is equal to 0, then
Independent of temperature.
independent of pressure. Independent of pressure. So here x by m became independent of pressure. Okay. Next question. The enzyme which hydrolyzes, the enzyme which hydrolyzes triglycerides to fatty acids and glycerol is called options maltase, lipase, gymase, pepsin.
The thymus.
Gymase. Gymase converts glucose into alcohol. Understood? So this is your answer. I'll give you answer. So the enzyme which hydrolyzes triglycerides. Triglycerides means esters. CH2O, COR, CHO, COR, UH, CH2O, COR. Okay, now break it here. Here, H plus, here OH minus. And what you're getting here? This takes place in presence of lipase, followed by hydrolysis. Now what you're getting, sir? Carboxylic acid or COOH or COOH. This is fatty acid plus remaining glycerol CH2OH, CHOH, CH2OH. Now this is the glycerol and RCOH, fatty acid. Fatty acids are nothing but which have long chains. Long chain carboxylic acids are called fatty acids. The next question. The right option for the statement Tyndall effect. This is the statement. Tyndall effect is exhibited by examples: urea solution, NaCl solution, glucose solution, last one, starch solution. What will be your answer?
Starch solutions.
Starch solution, because starch is a colloidal solution. So only colloidal solutions will exhibit a Tyndall effect, isn't it? Remaining are urea solution, NaCl solution, glucose solution. What are they?
Sir, option D.
Homogeneous.
Homogeneous. That means true solutions. That means true solutions. Did you understand? Next, one more frequently asking model. Which mixture of the solutions, previously asked also, which mixture of the solutions will lead to the formation of negatively charged colloidal soul. What is the colloidal soul? AZI I minus. So it is a negatively charged soul. But which solutions, which mixture will give this? A 50 ml of 0.1 molar AgNO3 plus 50 ml of 0.1 molar potassium iodide. Next, 50 ml of 1 molar AgNO3 plus 50 ml of 1.5 molar Ki. Next, 50 ml of 1 molar AgNO3 plus 50 ml of 2 molar Ki. Last option, 50 ml of 2 molar AgNO3, 50 ml of 1.5 molar Ki.
Sir, option C.
Why?
Option C. Answer is
Answer is option C.
yes, sir.
Why is it so? Why is it so?
Sir,
Why you said option C? Justify your answer.
yes, sir. The charge present on the colloidal, so it's due to the adsorption of common ions from the dispersion medium, sir.
Dispersion.
Medium.
Okay.
Then millimole of K is maximum, sir. Maximum in 50 plus 2 is 50 into 2, then 100. Hence, it acts as a solvent and anion is observed by the colloidal AgL formed, sir. Then the reaction is AgNO3 plus Ki. This gives rise to AgI plus KNO3.
So here the reaction is between AgNO3 plus Ki. What is the precipitate you are getting? AgI plus KNO3. This AgI precipitate should become negatively charged colloidal sol. When it will become negatively charged colloidal sol, when iodide ion is absorbed on it. So iodide ion concentration is maximum here when compared with all other 0.1, 1.5, 1.5. Here it is maximum concentration. So iodide ions are excess in the solution. So iodide ions are present in excess in the reaction mixture. So those ions only will adsorb, which is common in both. Right? So that is your answer, option C. Option C. Done, sir. Next. Next question. Which one of the following forms micelles? Which one of the following forms micelles? Options: dodecyl, trimethyl, ammonium chloride. Ammonium chloride. Next one, glucose. C, urea. D, iridium chloride. So what will be your answer?
Sir, I think.
Anyone? What do you think?
Sir, I think A.
Why?
Sir, because dodecyl trimethyl amine chloride is a cationic detergent.
Cationic.
Detergent, sir.
Yes. So this is cationic detergent. So soap molecules will form micelles, isn't it? This is the only soap molecule there, right? So it will form micelles. Answer. The next question. Which of the following reaction is catalyzed by? Which of the following reaction is catalyzed by maltase? Options: starch to maltose, maltose to glucose, lactose to maltose. Next one, maltose to glucose and fructose. Glucose and fructose. So which one is catalyzed by maltase?
Option B.
Option B,
Yes, sir. Option.
maltose is catalyzed by an enzyme maltase into glucose. Next question. Hydrolysis of ethyl acetate is catalyzed by aqueous options: sodium sulfate, potassium sulfate, sulfuric acid, and barium sulfate. Which one is your answer?
Sir, option C, H2SO4.
Option C, H2SO4. What is the hydrolysis of ethyl acetate? What is ethyl acetate formula?
Sir, it reaction CH3CH double O C2H.
COO C2H5 ester, sir.
Yes, sir.
Ethyl acetate hydrolysis in presence of a mineral acid. In presence of a mineral acid, right? So H2SO4 gives you what it will give, sir?
Sir, then CH3C double OH
CH3COOH
plus
plus
C2H5OH. OH, sir. Correct.
alcohol and carboxylic acid. So this is what we call ester hydrolysis. In organic chemistry, we will study this again, ester hydrolysis. Done, sir. In order to coagulate the impurities, next question. In order to coagulate impurities, present in water, which is the most effective ion, which is the most effective ion. Present in the alum. Compound is also given present in the alum. Options are potassium ion, sulfate ion, aluminum ion, last one, none.
Sir, option 3, aluminum ion.
Aluminum ion.
Yes, sir.
Why?
Alum the formula aluminum alva, sir.
In alum formula, potassium is also present. Then SO4 minus 2 is also present. You know alum formula, potash alum, sir. Potash alum is used in the purification of water. So K2SO4 double salt, Al2SO4 taken thrice, 24H2O. This is a double salt, sir. Now, according to your answer, potassium ions are present, sulfate ions are present, aluminum ions are also present. But in order to coagulate, what is the most effective ion? Already we discussed coagulation. Coagulating power as charge increases, higher the charge, more will be its coagulating ability. Then your answer will be Al plus 3. Right? Your answer is correct, but you should be able to justify your answer. Did you understand?
Yes, sir.
So this is about surface chemistry. As this chapter is only theory, no need to worry. Just practice questions from your material. Okay.
Okay, sir.
So tomorrow I'll start organic chemistry then. So that's it for this session. Meet you tomorrow. Good night, all of you.
Thank you, sir. Bye, sir.
Bye bye, all of you. Good night.